Horizontal spinner versus vertical spinner. A classic matchup almost as old as the sport of robot fighting itself. With modern bots being more powerful than ever, these weapon-to-weapon exchanges push the limits of what our machines can withstand. So to survive them, we have to push the limits of what we can build. I'm Nick, weapon designer for Team Bloodsport, and this is part 2 of our blade design series. Last time, we talked about our protective disc weapon. This time, we're taking a look at another new addition, the THICC bar. In 2019, our original long bar managed to survive some really nasty weapon hits. Stability proved to be an issue, with the bot going out of control after being knocked out of plane, and we also chipped a tooth, but the bar stayed on the bot and in one piece. That same year though, we saw some of the best horizontal bars in the game broken in half by vertical opponents. As an overhead spinner, the length of our bar works against us in an out-of-plane hit, and we knew that we would need to step up our durability if we wanted to take on big hitters like Bite Force, Death Roll, or Endgame. And so, we designed the THICC bar. In order to design for a vertical impact, we needed to understand the load we'd be seeing on our bar. When a vertical load is applied to the end of the bar, this creates a bending moment. The longer the bar, and the greater the force, the more bending stress it will see. The biggest stresses happen at the top and the bottom of the bar, because the top is pushing against the bending moment, while the bottom is pulling against it. The thicker the bar, the more leverage these reactions have, making the bar stronger against bending loads. While the long bar was 3/4 inch S7 tool steel, the THICC bar is 1.25 inches thick. We don't have weight for a solid 1.25 inch bar, so we designed pockets into it while still making it stronger than last year. The idea is to shape the cross-section of the bar like a piece of U-channel, and then widen the walls toward the center of the bar where the bending loads will be greatest. In the simulation at least, it's an improvement. To avoid chipping teeth, we went with a neutral rake angle, and also rounded the tip slightly to avoid sharp, fragile corners. We also made the bar reversible, which both supports the corners better and makes it so that we can spin it in reverse when the leading edge wears down. The reversible profile also helps us play mind games with opposing drivers who plan their angles of attack based on what direction our blade is spinning. Unlike our other new weapons, the THICC bar is assembled in multiple parts. The tri-bar and the disc are 3-armed shapes designed to be stable on their plane of rotation. 2 thicker arms are stronger than 3 smaller ones, but a straight bar is an unstable shape. We'll get into the physics of that in another video. However, through simulation and small-scale prototyping, we found that a pair of stabilizer wings help us avoid the worst of the instability effects of a bar, which should hopefully stop us from throwing ourselves out of the box after a big uppercut. After a fairly involved manufacturing process, linked to that video in the description, the THICC bar is ready for the Battlebots. Check us out on Battlebots, airing Thursdays at 8 p.m. on Discovery. And let us know in the comments who you'd like to see us use it on, and which blade you'd like to see us review next. Thanks for watching!